Hello, welcome back to Algebra. We've been talking about factoring the sum of cubes and also factoring the difference of cubes. We've left the formulas on the board. If we have an expression that is the sum of two things that are cubed, then we can write it as we have written here. If we have the difference of two things, two terms that are cubed, we can write it as what we have done here. And in the last section, we proved that all this was true and we solved a few, I guess, fairly easy problems. Now we'll crank up the complexity just a little bit, but the main idea is going to be the same. We're going to apply these formulas. It's just that as the expressions get a little bit more complex, there's more chance for error. So let's walk through them. We'll start with a little bit of an easier one, and then we'll go from there. What if I give you as an example or as a problem, I say, hey, let's go ahead and let's write this, or let's take this problem as x to the 6th power minus y to the 6th problem, and to the 6th power. So x to the 6th minus y to the 6th, and I say to you, I want you to factor that expression. First thing you want to do is try to look for something common here, but there is nothing common because there's only x's and y's and they're in different locations, so you can't pull out anything. Then you start thinking about special cases. Now, obviously, we don't have a rule for x to the 6th minus y to the 6th, but we do have rules for cubes. So one thing you might do right away is you might say, well, I can write this as the difference of two cubes, right? Of course I can, because x to the 6th can be written as x to the 2nd power, but then also raised to the 3rd power, because that'll give you 2 times 3 is 6, that'll give you x to the 6th power. And I can write that second term as y to the 2nd power, also raised to the 3rd power. So this is the difference of two cubes, and you could apply this rule to it, and you could get the answer, no problem at all. And I think that's a perfectly fine way to do the thing. But I want to do it a little bit of a different way, just to give you a little bit of a different flavor, to show you that there are multiple ways to tackle any problem. I can write these expressions like this, of course, but I can also write it like this. I can say that x to the 6th minus y to the 6th can be written as, instead of x squared cubed, I can write it as x cubed raised to the 2nd power minus y cubed also raised to the 2nd power. When you think about it, 2 times 3 is 6, 3 times 2 is 6. This is still going to give you x to the 6th power. This is also, for the same reason, going to give you y to the 6th power. So this is a perfectly valid way to write this expression, and this is also an equally valid way to write exactly the same expression. These two things, in other words, are equal to one another. And I can work with either one if I want to simplify. If I want to use this one, then I'll go to the difference of cubes. I'll identify A, I'll identify B, I'll stick it in there, maybe simplify a little bit and get the answer. But I want to work with this one because I want to show you that there are multiple ways to do that, to do these problems. Now, if you think about it, what does this look like to you? It's something squared minus something squared. Have we talked about that before? Something squared minus something squared. That's the difference, meaning subtraction, of two squares. We've done difference of two squares, factoring, in the last couple of 2 sections ago, 2 or 3 sections ago, right? And to refresh your memory, when you have the difference of two squares, let's switch colors a little bit. When you have the difference of two squares in general, if it's a squared minus b squared, just any two things that are squared and subtracted, you can always write it as a plus b times a minus b. If you do the FOIL on this and multiply, you're going to get a cancellation. This will give you a BA term, and this will give you a negative BA term. So the interior terms will add to 0, and you'll end up with the a squared minus the b squared. That's why it's equal like this. But now we know that in this example, I have something squared minus something squared. It's just that the a term happens to be x cubed, and the b term happens to be y cubed. So in order to use it, we're going to just plug it in like this. To use difference of two squares, we have to know what a is. A is x cubed. That's what's being